Welcome to this explainer. Today, we're looking at a massive technological shift that is completely transforming how we learn to navigate the roads.
I want you to think about this for a second. Commercial pilots spend hundreds of hours in highly advanced flight simulators before they are ever allowed to fly a real passenger jet. I mean, it's standard practice, right? It saves lives, it builds essential skills. And yet, for decades, everyday driver education was essentially just a quick classroom session before throwing a nervous teenager directly into live traffic. It sounds kind of crazy when you say it out loud, doesn't it? Well, thankfully, that is finally changing. Today, we're breaking down the rise of driving school simulators and how this incredible technology is revolutionizing safe driver education.
So ask yourself, what if a driver's first crash had absolutely zero consequences? It's a really powerful thought, and honestly, it's the ultimate high-stakes value proposition of this whole simulator technology. Look, driving is inherently dangerous, and the learning curve is steep. Mistakes are just a natural part of learning anything, but behind the wheel of a 2-ton vehicle, a novice's mistake can be fatal. Simulators completely remove the physical danger from that learning curve. They allow a driver to make that first critical error, to panic, to brake way too late, or to oversteer, and walk away with nothing more than a bruised ego and a really valuable lesson. It completely changes the psychology of learning to drive.
Here is our quick roadmap for today's explainer. We'll start with the safe driving revolution, then look inside the simulator tech, explore the real benefits with zero risk, discuss simulator types and limits, and finally, look at the future of driver ed. Let's get right into it.
Okay, let's dive into this. Section 1, the safe driving revolution. High stakes, zero risk.
The core concept here is that simulators provide foundational training in a perfectly controlled virtual setting long before a student ever turns a physical ignition key. And you know, this isn't just for nervous teenagers taking their first lesson. This revolution applies really broadly. For instance, fleet trainers use these systems to prepare truck and bus drivers for incredibly hazardous cargo protocols or super tricky routes. Even rehabilitation centers are using them to safely assess and retrain drivers who are recovering from neurological conditions or severe injuries. It is an indispensable first step that guarantees safety while building fundamental confidence.
Moving right along to Section 2, inside the simulator tech, under the virtual hood.
And this brilliantly illustrates how the systems actually work. It all basically comes down to an intricate dance between hardware and software. On the hardware side, you have a physical cab, so a real steering wheel, pedals, maybe even high-end motion platforms that vibrate and tilt to simulate acceleration or bumps. But here's the thing, none of that matters without the software side. The physics engine is constantly calculating vehicle dynamics, like weight transfer and tire grip, literally in milliseconds. So when a student slams on a physical force feedback pedal, the AI traffic and the 3D world instantly react to show exactly how that car would behave on a slick, wet road. It's just a seamless, amazing loop of action and reaction.
All right, Section 3, real benefits, zero risk, maximizing ROI and driver safety.
For driving schools and businesses, the financial wins here are massive. I mean, you are saving thousands on gas, on wear and tear, and on insurance premiums simply because the real cars stay safely parked. Plus, you're maximizing actual productive road time. By the time a student gets into a real car, they already know the clutch bite point and the steering feel, making the actual road lesson vastly more efficient. It's also highly scalable. One single instructor can monitor multiple students concurrently. But my absolute favorite part? The data. Instead of an instructor just guessing if a student was tailgating, the system provides objective hard metrics, like exact reaction times and following distances down to the millisecond.
Let's focus on one specific, literal, life-saving application: hazard perception. Think about real-world driving lessons for a second. You can't safely take a student out and intentionally induce a tire blowout at 65 miles per hour, or purposely force them onto black ice just to see what happens. It's impossible. But in a simulator, you can run that exact, terrifying scenario 10 times in a row until they build the real muscle memory required to calmly steer into a skid or manage a sudden obstacle. They survive the rarest, most dangerous events before ever encountering them in reality.
Next up, Section 4, simulator types and limits, finding the right fit and facing reality.
So if you're looking into this, here is your progression of purchasing options. Step 1 is the desktop setup. Very basic, low cost, just a monitor, wheel, and pedals. It's great for learning basic rules. Step 2 steps up to fixed-base simulators, giving you a full cockpit for core procedures, but without motion. Step 3 gets really serious with motion-based rigs. These are the high-fidelity, expensive setups where the whole cabin moves, absolutely essential if you're teaching advanced dynamics like truck rollover prevention. And finally, step 4, the rapidly growing VR headset market, which offers incredible 360-degree immersion and depth perception, often with a much smaller physical footprint.
So, the crucial point is this reality check. Simulators are brilliant, but they definitely have limits. Yes, virtual mastery gives us zero-risk learning and repeatable hazardous scenarios. But we still have real-world necessity. A simulator just cannot perfectly replicate the nuanced physical feel of tire grip giving way on gravel. And more importantly, it lacks true psychological stakes. Deep down, your brain kind of knows it's a game, which can sometimes reduce actual risk perception. So simulators are a powerful complement to on-road experience, absolutely, but they are not a complete replacement. The real world is messy, and genuine human judgment under real pressure can only be fully tested on actual asphalt.
Which brings us to our final section, Section 5, the future of driver ed, where the technology is accelerating.
The upcoming advancements we're seeing are just incredible. We're moving rapidly toward dynamic AI-powered scenarios built on massive gaming engines like Unreal and Unity, making the graphics and physics hyper-realistic. Combine that with wider VR and AR adoption and cloud-based management, and instructors can essentially beam a localized, snowy driving scenario directly to a simulator anywhere in the world. But critically, we'll see deeper integration with ADAS, advanced driver assistance systems. As our real cars get smarter with automatic emergency braking and lane keep assist, simulators are going to be the primary tool to teach drivers how to actually interact with their own car's AI without fighting it.
This brings us to a really powerful summary from our source material today. Simulators dramatically improve the efficiency, effectiveness, and safety of the learning process. Integrating this technology is no longer just a neat little gimmick. It is a smart, truly transformative investment in public safety and educational excellence that builds safer, more competent drivers for the future.
As we leave the virtual roads behind today, it's really worth asking, how many lives could be saved over the next decade if every single new driver experienced their first major mistake in a simulator rather than on a busy highway? The technology's here, and the transition has already begun. Thank you so much for joining me on this explainer. Keep learning and stay curious. For more in purchase, visit our website, Ferris Solution.